Hi everyone, this is a second video in this series of looking at what to do with your SPSS data for your quantitative projects or dissertations. This one, what did we look at in the last video? We looked at downloading your data set from the survey platform you'd use and doing that data clean, that kind of tidy up of the data, getting things looking the way you want them for the analyses that follow. So in this second video, we're going to look at three particular things. We're going to look at that issue of reverse scores and what to do with those. Doing a reliability analysis, we'll talk through that. And then thirdly, creating mean variables. We'll explain what we mean by those things along the way. But these are going to be kind of standard common things that all kind of quantitative project students are going to be doing. Regardless of your area of topic focus and that kind of thing. So I've tried to keep things, really kind of open-ended here so that they work for all of you. But of course, as with any of these, if you have any questions about how this relates to your own project, just let me know. Just note them down as you're listening to this video, in fact. And that way I can help you and support you with any of those questions. So I've got open here a .sav file, which is, the standard SPSS dataset file with a variable view and data view. We're looking at data view now, and a .spv file, which is the output file. So you always have those two types of file with SPSS. You can always save both of them as well. You can save as many data sets as you like, as many versions of your data sets as you like. And you can save as many .spv files showing the analyses you've conducted as you like. You can save them all on one big .spv file or a separate ones for your different analyses if you wish. It's entirely up to you. You can run these analyses as many times as you like, of course. So it's about managing an admin burden, really. It's about having the amount of material that feels useful to reflect all of your different activities. So there are lots of ways to approach that. Right, so let's think about this issue of reverse scoring then. So I've got a slightly sort of moved on data set here from the one you saw last time. You can see I've got the narcissism items that have started to be sorted out a little bit. To do this, I'm going to refer to another document actually, which is my one of the scales I'll be using for this that goes along with this scale with this particular survey, and that's the dark triad scale. So the main scales we'll be focusing on are this. Let's look at the narcissism scale again. So clearly you may not be using a narcissism scale yourself, but you probably won't be using a scale that's that's that dissimilar in terms of how it's been designed and how many items it has and that kind of thing. So try to think about how this relates to your project rather than getting sort of stuck in this idea of working through the example of the narcissism scale. Okay, so this data set we're looking at now is from a research project I did a few years ago, looking at dark triad trait predictors of alcohol consumption intention. You can see here in variable view we've got lots of dark triad items. You'll have seen from my previous video that I favor this kind of quite brief way of phrasing things, just having N here representing narcissism, these P items representing psychopathy. As with the last scale video, I won't go through all the different scales here. I'll keep things stripped down and simple so that we're just focusing on one thing at a time here. But let's get to this issue of reverse scores, and let's think about the narcissism items here. Let's make them our focus so that we've got some kind of focus here going on. So the narcissism is scale is a 9-item scale. It's part of the 27-item SD3 measure, measuring the dark traits. And some of these items are reverse scored items. What do we mean by reverse scored items? Well, Narcissism item 1, I'm highlighting now. You can't see this here because I don't include this information in the SPSS file itself, but I do refer to it on the scale items that I need to be looking at to know what narcissism item 1 is about. But the phrasing of that item is, people see me as a natural leader. Now we have a 5-point Likert scale for each of these scale items, with 1 being strongly disagree, all the way through to 5 being strongly agree. Now, high scores on that item, people see me as a natural leader, high scores being strongly agree, that would suggest high levels of narcissism, wouldn't it? You know, a highly narcissistic individual, someone who strongly agrees with the statement, people see me as a natural leader. However, we look at item 2, I'll read that one out. I hate being the center of attention. Now, if I strongly agree with that, that suggests the opposite of being high on levels of narcissism or being a highly narcissistic individual. So in fact, it would be low scores on that, confusingly, that would suggest a highly narcissistic individual. If you strongly disagree with that statement, it suggests narcissism. So that is an item that we would call a reversed score item. We've actually got 3 of them out of the 9 items in this narcissism scale. Item 2 is reverse scored, item 6 is reverse scored, and item 8 is reverse scored. So item 2 is I hate being the center of attention. Item 6 is I feel embarrassed if someone compliments me. And item 8 is I am an average person. So strongly agreeing with any of those is going to not suggest narcissism, it's going to suggest lower levels of narcissism. So we need to correct those so that high scores for all these 9 items always means high levels of narcissism. Now you can see that I've already done this for these 3 items, but let's pretend I hadn't for item 2. I'm going to keep those ones in, but I'm going to delete the reversed item that I've already created for N2. So I need to create a kind of corrected version of this reverse score item. Now, there are a number of different ways to do this on SPSS. I'm going to show you the one that I like, but you might find another way through reading about it in a book or a YouTube video or something like that. This is how I do it. I go to transform, compute variable. I give the new variable a title that's going to be really clear and easy to read. I like this, just putting a capital R at the end, which says to me, that's the one you've changed. It's a reverse score item and you've now corrected it. You might have your own way of phrasing that. Then we go to this numeric expression box here. Now, what you need to do there is put in kind of the mathematical equation for what we're going to be doing with the existing numbers or numbers that we put in this box to create the new target variable, N2R. And to create a reverse score item, you need to take the value that's 1 value higher than the maximum value of the scale and minus the scale item. Really is that simple. So here is a scale of 1 to 5, so 1 higher than that is 6. So I'm putting in 6 minus N2. You can also just swish them across like this. Put 6 minus N2, or you can type it. And then I'm going down to the bottom and pressing OK. I don't think you can see that output box there, but we can just pan down to the bottom of the set and look. Our new item has been created. Now I'm going to tweak this a bit so that it looks like the other items. The more I can do to make things sort of clear for me to read, easier my job is. So some time invested there is helpful. So I'm going to change that to say 0 decimals there. I don't want lots of numbers appearing there. I want a nice kind of easy to read data set. I'm going to copy and paste the same thing in the label column as in the name column. That's how I like things to look. I'm going to change that to left alignment. I'm going to have that as a scale variable in measure. Not that it makes any difference at all to how things are analyzed. Then I go to data view, and there it is, N2R. It's appeared right next to N2. Kind of makes sense to have them together. And just to illustrate what's happened there, if we look at N2 and we're thinking, hang on, has N2R really, is that really the reverse? Is that really the reverse version of N2? Well, the 3s are going to stay the same in both. The 1s have gone to 5s. What was a 1 in N2 is now a 5 in N2R. What was a 5 in N2 in row 5 is now a 1 in N2R. 2s have gone to 4s. 4s have gone to 2s in row 14 there. So I'm pretty happy looking at that, but yes, I've successfully reversed N2. So the high scores on N2R are going to mean the same for high scores on N1, N3, and N4, for example. So we needed to do that with any reverse score items in the narcissism scale. It happens that there are 3 reverse score items, and the other 2, apart from N2, item 2, are item 6 and item 8. And there they are, and I've already fixed those. We can see if we look at those that we've got, you know, the inverse numbers in the reverse score column relative to the standard item, and the same for N8 and N8R. So that's what reverse scoring is. Why do we have those reverse score items in the first place? Why do we have items, you know, where high scores mean different things for different items? Because we want people to provide high quality answers. We don't have a narcissism scale where we have a single item saying, are you not, I'm a narcissistic person, strongly disagree to strongly agree. We try and think of the kinds of questions that are going to get people to think and get people to be as honest as possible and as accurate as possible about the kind of person they are. And part of the process of doing that means phrasing things in different kinds of ways. So you have some items that are like, you know, people see me as a natural leader, strongly agree. Other items that get people to think about things another kind of way. I hate being the center of attention. Low scores on that as it stands at the raw item being high levels of narcissism. So that's why we have the reverse score items for high quality data, more accurate data. When it comes to this stage, we want high scores to mean all the same thing. So that's reverse scoring. Let's move on to reliability now. Now we move on to reliability because that's kind of where we can go once we've got a set of scale items where high scores all mean the same thing. We can't do reliability analyses or compute mean variables when we've got reverse items that are uncorrected, where we've got high scores meaning different things within a given scale. We have to correct the reverse scores first. Now, why do we do a reliability analysis? Well, we might have knowledge about reliability for a given scale from the surrounding literature. We might have, you know, evidence of good scale validation for the SG3 scale for the dark traits, for example. But we're always in a new starting point with any new data set. So we need to see what the reliability is for our particular data set. How do we measure reliability? If you've just got a 2-item scale, you can actually just use a Pearson's R correlation. That's your statement of reliability for a 2-item scale. And normally you're going to have 3 or more items, normally around 10 items, I should think, for a typical scale that you use in psychology, a personality scale, for example. So you're going to need to use a different metric for that, and that's a measure called Cronbach's alpha. It gives you some statement of how internally consistent, how reliable your set of scale items are, how well they go together. It's some statements around that. Now remember, you compute reliability by scale. You don't have a reliability value for, you know, the dark triad. You have one separately for narcissism, Machiavellianism, and psychopathy. Yeah? Okay, so how do we do this reliability analysis? Well, we go to Analyze, we go to Scale, we go to Reliability Analysis. I think you see this window here. add in all the items we want to do a reliability analysis on the narcissism items. Now I'm lazy. I just pull them all across like that. I highlight them all and pull them all across. But then I've got to go back and remember which ones I want to remove that aren't going to be included. So remember that N2 item, high scores on that meant something different. I'm going to cut that one out and just keep the N2R one in, where high scores mean the same as N1 and N3, for example. And similarly, I'm going to remove N6 and just keep N6R. And I think you guessed it, I'm going to be removing N8 as well, because I've got N8R, where high scores mean the same thing as the other scale items. So they've all gone into the items thing. I don't have to worry about that box there. I look at statistics. I'm going to tick scale if item deleted, and we'll come on to see why in a moment. That's all I'm selecting from that menu. So I press continue. I'm going to get a Cronbach's alpha, it says that in this section here, and I press OK. And here, you should see this, because I've shared this output screen as well. Here we get a reliability analysis. And what do we get? A reliability of 0.725. Now, Cronbach's alpha of anywhere above 0.7 is acceptable reliability. So the reliability here isn't fantastic, but it's acceptable. It's good enough. So we'd round that up to 2 decimal places, 0.73, and report that as our reliability. Now, one other thing we check here is whether or not removing any of the items would push up that Cronbach's alpha a bit. That's why we tick that Cronbach's alpha if item deleted box when we ordered up reliability tests. So I'm looking down this column here thinking, are any of these values higher than 0.725? And the answer in this case is no. So this is telling me that these items go together pretty well as a set, and that there isn't one that's a particular outlier here. There isn't one that's kind of letting the side down, where if we removed it, it would push up and produce a substantially more reliable scale. So there's a pretty good internal consistency here between these items. If we removed some of the items, the reliability would go down, but by removing any of the items, we wouldn't have a better reliability. So we're going to retain them all for our mean variable for narcissism that we're going to compute in just a moment. So what you'd report for your reliability analysis is 0.73 for this scale. And you could report that quite usefully in the measures subsection of your methods section. You could also report it in a standalone reliability analysis subsection of your quite early on in your results section. I think either of those approaches would be fine. Okay, that's reliability analysis then. And remember, you'll be doing it for each and every psychological scale. So you'll probably do about 4 or 5 reliability analyses for your project overall, depending on how many scales, how many psychological constructs you're measuring. It's going to vary a bit with your different projects. So we come on now to that final bit, mean variables. Here's where we can compute the variable that we're going to include in all the inferential analyses. So we don't worry about narcissism items 1 and 2 and 3 when it comes to our multiple regression. We just want to have a single narcissism item. You might be thinking right now, well, why did we bother having all these different narcissism items? Well, that comes back to this issue of construct validity. We don't just ask people, are you a narcissistic person? Or I'm a narcissistic person, strongly disagree, agree. It wouldn't be a very valid psychological measure. We need to be a bit smarter than that and ask them these different questions with these strongly disagree, strongly agree type answers, so that we're kind of coming in at different angles from this idea of narcissism, asking them different questions, these different facets of the trait, to build up some kind of confidence, some kind of sense of validity in the underlying psychological construct that we're attempting to measure. That's why we have all these items. But when it comes to running an inferential analysis, we're just needing the one kind of averaged out narcissism item, the average of all these items. What's the average narcissism score across these 9 items. We can see now why it makes sense that we had to treat those reverse scores. We needed to have high scores meaning all the same things, because if we had an average item now, we computed our mean variable with the raw scores, we get something quite weird. We get quite a weird average value that wouldn't be so meaningful. We've got to have high scores meaning the same thing to be able to do this. So how do we compute a mean variable? Well, there are a few ways to do this, but I go to transform again, compute variable. I reset it so that I don't have the previous value showing. In target variable, I'm going to put, what shall I put? I'm going to put narc mean, like that. That's what I want my mean narcissism item to look like. You can call it anything you want. Can't have any spaces in there, or SPSS won't like it. But you can give it any label you like, as long as you can identify it clearly. You can drag and drop from this menu into the numeric expression field. It's quite nice just to type here, as long as you're using the phrasing that SPSS will recognize for the variables you've already got in your data set. So you have brackets here, and you're just adding in all the different relevant narcissism items from your data set. Now notice that I've been careful there to add the reverse score items for items 2, 6, and 8. So those are the ones I want to average. And then I'm doing divided by, which is a /9. So it's all of the scale items added together for that scale, divided by the number of scale items. Press OK. Back to our SPV file there. Let's have a look. Let's see if it's created my narcissism item. Yes, great. So I put that in label. That's how I like it. I'm going to have one decimal place here because I'm going to have a bit more variability now that I've got an average variable. So it'd be nice to see what those values are below the decimal point. I'll change that to left alignment. And let's have a look. Let's see how it compares to the standard items. So we've got them all together. There we go. So for row 1, you can see we had different responses there. Let's move those out because they're kind of redundant. So what did we have? 4, 3, 4, 1, 3, 3, 2, 3, 1. So quite a spread there of responses for that first participant. And we've got a mean narcissism, which is pretty much bang on average, 2.7. What else have we got? Where's a high scoring one? Well, the 4th row here, responses of 5, 5, 5, 3, 3, 5, 5, 5, 5, an average item of 4.6 for that participant, and so on. So we can see there that we've got all of our new variable created, which is going to be the variable we include in all of the analyses going forward. For the correlations and the multiple regressions and the descriptive statistics. But I'm going to cover that in another video. So in this video, cover quite a lot, haven't we? We've covered reverse scores, reliability analyses, and mean variables. And remember, you'll end up with a mean variable for each of your different scales. You'll have a mean narcissism item, mean Machiavellianism item, mean psychopathy item, and mean intention to drink alcohol for this data set. Have a mean item for that as well. And they're the ones you include in your subsequent analyses. Okay, I hope this video has been useful. Please get in touch with me with any questions that have come up in terms of how all this links up to your own project. And I'll see you in the next video where we're going to go through descriptive statistics, correlational analyses, and multiple regression. See you there.